Good day everyone, this is example 8.3. So for this week we are moving on to synchronous modeling as well as using the surface features inside NX. And as you've probably seen from the previous two videos it's quite useful tools when modeling something inside NX. So what I've made for you today is like a weird looking bedside lamp, if you want to call it that. So it just has a base and then some helix shaped arm going upwards, and then the top where you'll typically put in the light bulb. I don't think you actually get something that looks like this. It might be cool to make something like this, but yeah, this is just to show you the different features. So I'm going to show you how to create this. You'll see there's quite a lot of information. So once again, a front view and a right side view, and then just a top side view of scale 1 to 2, just to show you how it looks from the top. So and that's the isometric view of the model. So going to NX, I'm going to start with a base. So you'll see that the sketch origin is situated there, which is in the middle. X to the right, Z to the upwards, and then Y inwards. You'll also see there is Y inwards. And it's important to note from this one, it's the origin is somewhere or some distance away from the body, and you'll see why this happens, but it's important to get the position of the origin correct. Yeah, if you get this wrong, you typically only have the z-axis correct, but that's only if it's in the middle. For this one, the z-axis won't be 0 as for many of the previous cases. So yeah, let's move on to the part. So inside NX, I'm going to create my sketch on the front plane. So Z upwards, Y inwards, X to the right. Let's just change that one. So on the front plane, and then you'll see it's 100 millimeters wide, 100 millimeters deep, 20 millimeters high. So I'm going to create this. Let me just zoom in a bit before I create it. So 100 wide and 20 high. I'm going to place it there. Then I'm going to use my geometric constraints just to horizontally and vertically align it. And this is important to get the sketch origin at the correct position. So now it's in the middle as for this one. So I'm going to finish the sketch and extrude it, and it's extruded 100 millimeters deep. So let's extrude that. It's 100 and in the other direction. So either double click there or just on that arrow. So it's important. It's not in this direction. That's not correct, because then your sketch origin would be on this side, and it's not. It's on the other. So that's the correct way of doing it. So that's the base, but now you'll see there's some angular feature on all sides. Now you can either create a sketch on each of the sides and extrude it or subtract it from the base, or you can use the synchronous modeling tool, such as drafting. So by using drafting, I can draft some of the faces of the model. So it will typically automatically specify your vector, and then as you select your faces, it will choose the correct vector. So now important, you can either select the face, a edge, a tangent to face, or parting edge. And for my case, I'm going to use face. My stationary face, so this is the face that's not going to be modeled away. So this would be the bottom. So if you look at this, you'll see that the bottom stays 100 millimeters wide, and then the top face is drafted away. So my stationary face is that one, and then the faces to draft is all 4 faces on the sides. So you'll see all of those faces are drafted. And the angle is given here as 25 degrees in the typical, so it's for all 4 of the faces. So that's 25, and then I'm going to select all 4 faces. So you'll see it drafts it away as you select them. And once you click OK, there you have your base. So now you'll see, as I said earlier, the sketch origin is not on the model, and that's because it's the model is drafted away at that position. So So that's the base. Now the next thing, now it can be quite tricky to determine what to do next, but yeah, since I've made a model, I know exactly what to do. But you need to create this helix. Now, how can we create some other feature along a vector that's not straight or in the z, x, or y axis? And this can be done by using the swept function. But first, you need to create the helix. So I'm going to create this curve, and then I'm going to create a helix along that spline, and then from there I'm going to create the extruded feature. So first of all, I need to create that curve. Now you'll see it's in the middle of this feature. So in the middle here, and it's in the middle here. So I'm going to create a datum plane for myself. So half of 100 is 50. So I'm going to select that one, and it's 50 millimeters. So it will typically be there. But NX remembers my selection for previously, so that's 50 millimeters. Now you'll see that's in the middle, and you can drag this one to the top so that you can see it, because you'll see it disappears if I click OK now. But I'll just show you how to deal with that. So there's my datum plane. If I click OK, now it's gone. I can't see it because it's inside the model. So if you go to a wireframe, okay, it doesn't show there also. So, but it is there. If you click on that, okay, so it's not showing if I click on that, but I want to create a sketch on that datum plane. So I'm going to create my sketch, and I will see, you can also not see it inside the model now. I cannot select it, but you can click on that one there, and it will select the datum plane that you've created. And I'm just going to reverse the direction so that I sketch from the front. Okay, so now the dimensions for this curve is, firstly, it's 50 radius, typical, which means both of them are 50. So I'm going to create my arc. You'll see that it's from the top. So it's from there. Select the midpoint, radius 50, somewhere there, and it's curved to that side. And then the second one is also radius 50, somewhere there, and it's curved to that side. And it's important to note that there's a coincident constraint between the two lines. So you'll see it needs 3 constraints to be fully constrained. So the first one is 50 millimeters from the sketch origin, that point. So it's that point. So I'm going to create a dimension from there to there. It's 50 millimeters. And then you'll also see that from the sketch origin to the top, so that point there is 90, which means that needs to be 40. So you can either specify it from there to there, or you can specify it to there. So I'm going to do this. That's 40 millimeters. Okay, now you'll see the sketch only needs one constraint. So I've decided so that there's a perpendicular constraint there. So you can either create a perpendicular constraint, geometric constraint between this line and that line. And now you'll see the sketch is fully constrained. Or I'm going to use as specified in the sketch. So you'll see from the z-axis to that point is 40 millimeters. So I'm going to create that dimension from there to there. The horizontal dimension is 40. Okay. And now you'll see the sketch is fully constrained. So that's the curve that we need. And this curve is purely just to have a spline to create the helix on. So I'm going to finish this. Okay, so the helix feature you can get at curve. So there you see it's a helix. And I'm going to select it. Let me just deselect that curve so that I can show you how to. Okay, so you'll either select along a vector, so then you can select a straight line or one of the axes, or you can select along a spline. Now a spline is a feature or sketch inside the model, and this is my spline. So I'm going to select it, so the first one and the second one. Okay, and now you'll see that the helix settings is provided to you, so it's along a spine, sorry, not a spline. The code word for today is glass. So along a spine, then you'll see the angle is 0 degrees, the size law type is constant, the value is 20 millimeters, pitch law type is constant, and the value is 5 millimeters as stated. Length method is limits, and then start limit is 0 and end limit is 100 millimeters. Okay, so that's correct. That's just because NX remembers my settings from when I created the model, but you'll typically need to include all of these. But all the information is provided to get it exactly the same. So then I'm going to select OK. Okay, so there I have a helix, but it's only a sketch. It's not a model such as this thing that looks like a spring. So to create that spring, we need to create a circle that we can extrude along this helix. So how are you going to do that? I'm first going to create a sketch, and this sketch is not going to be created on a plane. It's going to be created on a path, and the path is one of those. So it's somewhere a path inside your model history, and my path will be the helix, and you'll see it select the point there. And that's all I need. So you can select normal. So if you just show you the select, it's important to have a let me create it again. So it's quite an important thing to see. If I create it on the path, it's important that the orientation is normal to the path. So if you select normal to vector, you can then choose a vector, parallel to vector, 3 axes, but mine is normal to path. Okay. So then I'm going to create this sketch. So let me just because that point needs to be on the point of the helix. So I'm just going to select it again. Okay, and I'm going to move it to the point. So you'll see you can drag it along the spline. Okay. Okay, and there it is. Now I can create my sketch. So you'll see that it's specified the diameter of this helix is 2.5 millimeters. So circle on the sketch origin 2.5. So that sketch origin's orientation is not that important. It's just for the sketch. We'll hide it in any case after creating the sketch. So there I have a circle. Now you can ask the question about how I'm going to extrude something that looks like this. So that's quite easy. You go to surface and then swept. And by using the swept function, I can then sweep this curve along another curve, which will be my helix. And give it a moment, and there you have it. So click OK, and it creates a nice spring looking feature. So now it's important to know that these are two separate models, and to be able to have the correct answers, you need to unite them. So I'm going to use my unite function and unite these two. And click OK. So now they are one part. So the last feature we need to add is this lamp holder on the top. So what I'm going to do is I'm first once again going to create a block. And to do this, I'm going to create once again a sketch. And this sketch is going to be created on a path, and that path will be that sketch there. Okay. Just going to make sure that it's at the point of the sketch. So move it up and click OK. Okay. So there you have it. I just want to reverse the direction. So let me, I'll do it from scratch. So sketch on path. That's my path. Make sure it's at the point. Just reverse the direction so that I'm sketching from the top. Let's see. Okay, and now I'm going to create a rectangle. So 50 millimeters by 50 millimeters by 50. So it's a cube. So 50, 50. Okay. And geometric constraint. So these two needs to be vertically aligned and horizontally aligned. Okay. And finish my sketch. Okay, so now I'm going to extrude it 50 millimeters to the top. Just specify that. Okay, and now you can unite it, but because there's some other features you still need to add. I'm first going to do this, and then I'm going to unite it. Otherwise, it wants to, for instance, the shell feature, it wants to shell the entire the model instead of only this block. So I'm going to firstly draft it. So once again, 15 degrees, all four sides. So if you remember correctly, my stationary face will once again be the bottom face, and my face is draft. Okay, 15 degrees will be these four. So it's very easy to use the draft function, and there you have it. 3 seconds. Okay, so the last thing to add is then the shell feature. So this once again is a nice synchronous modeling feature. Not really, but it's a nice feature. So shell, you can either select it as closed or open. So for closed, this is going to create a hollow model, but it won't have any openings. For open, it will open one of the faces and shell the entire model or part. So my face that I want open is that one. Thickness is specified, shell is 2 millimeters. And okay, so now you'll see if I zoom in there, it's shelled, so each of the sides are 2 millimeters thick, also the bottom. And that's that. So lastly, we have not yet united this feature. So I'm going to use my unite function, unite that part with that part, and click OK. So now they are one part. The material is bronze, so I'm going to specify my material to that part as bronze. Click OK. And now we will show you in class as well, but I'm going to show you in this video as well. So to measure, you have done this solid body. Okay, so to ease the marking process and to automatically update your weights and or mass and your center of mass, but most importantly to make the marking more easy so that we can provide you faster with your marks, is that you can select. So if you hold on that, you can see that it displays non-associative annotation on OK or apply. So we would like you to select everything that you need to enter inside Ifundi, or for answers you should select those. So in class we will provide more detail on this, but once you've selected them and you click OK, you'll see that it displays it inside the modeling environment. And so now we can only open the part, see, okay, your answers is correct, full marks, or answers is incorrect and we don't give you full marks. But yeah, that's besides the point. It's just so that we can just open the model, because otherwise we need to open each of your models individually, go to analysis, measure, and that takes quite some time. So please do this. And yeah, this is the example video for example 3 of week 8. I hope you enjoyed it, and see you in class. Cheers.